Hey, welcome back, you guys. We are going to talk about solving systems of equations today. But today, we're going to do more exciting stuff. We're going to do nonlinear equations. That's got to be the coolest thing you've learned all day. Especially, no, actually, you probably were learning this last hour, huh? Oh well. So, we're going to learn nonlinear stuff with two variables. I'm excited. I think you should be too. It's going to be fun. You're going to love it. It's going to be some of the most fun you have all day. So let's talk about the different types of stuff you're going to see. This is what you're doing. Nonlinear means, in this case, there's a whole bunch of nonlinear stuff. But in this case, for this class, we're talking about this bad boy right here. This is a parabola. Okay, goes on forever on the edges. So you're going to have probably a linear. I think I checked all of them are one linear, so a straight line, and a parabola. So remember, solutions, how do you spell solutions? Solutions equal intersections. That means a solution is wherever the two graphs touch. So here are the different possibilities of what could happen. You could have a parabola that gets missed entirely by this straight line. Because this thing is curving up and away from this straight line, these are never going to touch. That means you're going to get no solutions. It's possible to have zero solutions. We might look at some where we find the imaginary solutions, but, you know, zero real solutions. Maybe we should put a little, like, real in there. Okay. The other possibility is you have your parabola, and your straight line comes and just barely taps the edge right there. Just taps it, right, in one spot. This would be one solution. For those of you who want to go on to do math for the rest of your life, which is probably none of you, the fancy word for this is tangent. So you might, I don't know, you might use that someday. Maybe not. Maybe someday when you're old enough to go to bars and play this wonderful thing called trivia. You know what, you guys, I just thought, what if we never have trivia again because of COVID? That would be awful. I can't wait to tell my grandkids about trivia. They'd be like, Grandpa, tell us a story about when we could meet other people, right? I'd be like, let me tell you kids, trivia. Anyway, if a line comes really close, touches in just one spot, and then goes away, that thing's called a tangent. Save that bad boy. Save that word for if you ever get to go to trivia. I've gotten so many free flatbreads off this thing. It's super great. All right. Two solutions. This is like the most common one. You've got a parabola. This line goes through. It's going to hit in two spots. This doesn't have a fancy name. This is just what usually happens. Cool. All right. So let's go look at some examples. So I'm going to try and do these using substitution. We'll try one with elimination. And then this third one is going to have no solution. But I just want to show you kind of like what happens and how you know it's no solution. Because otherwise you're going to like give yourself an aneurysm trying to solve this thing and you're going to get frustrated. So I just want to talk about it. So let's try the substitution one. Remember, substitution is a good option anytime you have one variable isolated like this. So this one might be a good one for substitution because you have a variable isolated, but you know, we'll get there. So we're going to substitute. We're going to take x plus 2 and we're going to plug it into that y. We're going to substitute it. So when we do that, we have x plus 2 equals x squared plus 3x plus 2. All right, this is what you have to solve now. So you have to think way back to Algebra 2 and remember how to solve a quadratic. The first step you want to do from here is move everything onto one side. You don't want side sharing. That's going to make, if you have stuff on both sides, it's just, don't do that, okay? So we're going to move this stuff over because we want to keep the x squared term positive. So we're going to subtract x, and we're going to subtract 2. All right. These cancel. This side 0. That's what you want. Bring down that x squared, because we don't have any like terms with it. 3x minus 1x is 2x. And 2 minus 2 is 0, and those go away. All right. This, I've luckily given myself a super easy example because I'm a nice guy and I don't want to struggle. So what you want to do from here, even if you have another number there, your goal is to try to factor. Okay. So on this, I have a GCF. Both of these have an x, so I'm going to factor the x out. I'm not doing anything with this equals 0, so just bring that down so you don't forget it. Equals 0. Whoops, sorry, too many zeros there. So we're going to factor the x out. It doesn't disappear. It just goes out in front. Okay, we had 2 x's. I took 1 out. That means there's going to be 1 left. Here, I had 2x. Took the x out. I still have the plus 2. Okay, so this is factored. Now what you do is you set these two factors. This is a factor, and this is a factor. Set them both equal to 0, and that will give you your x's. So x equals 0, and x plus 2 equals 0. So x equals 0. There you go. X equals a number. This one's good to go. We're done there. Here, we need to move the 2 away, and we get x equals negative 2. All right. We are halfway done with the problem, but you've done like 80% of the work. We have our x values. We want to know where do these cross, so we need ordered pairs, not just x values. So let's go write down our x's. Now we need to plug these back in to whichever equation we think is easier to get y. I'm going to give you a hint. You got one guess on which equation is easier. The left one, Mr. Barton. Wrong. This one. Use this one. It's easier. There's no squared. So we're going to plug our x's into this, and that will give us our y values. So we have y equals 0 plus 2. 0 plus 2 is 2. Y equals 2. Because I plugged 0 in, this answer goes with the ordered pair where the x is 0. So 0, 2 is one solution. Now we need to plug in the negative 2. Y equals negative 2 plus 2. That's 0. Y equals 0. So these are your two solutions. Cool. There you go. You did it. We did a whole example, and it wasn't even that painful. All right. For the second one, we're going to do elimination. So let me just pretend that I want to cancel out the x's here. The first problem is the coefficients don't match. So let's multiply this by 3. So we have 3y equals negative 3x plus 18. Okay. Now we add. So this would be 4y equals, this doesn't have an x squared, so we bring it down. Negative x squared. Those cancel. That's 20. This doesn't work. You can see, because I don't have an x squared here, this thing will never, ever, ever, ever cancel out. So that's not an option. You are not allowed to cancel the squared variable. You can't do it. It's impossible. If you try to, variable. If you try to, you're going to just frustrate yourself because this thing doesn't have a squared to cancel with, so you can't do it. So if you want to use elimination, let's pretend it's your favorite type of solving equations. To get this to work, you have to cancel out the variable where there's only a first power. If you try the x, it's impossible. So we're going to make our y's cancel. To do that, we're going to multiply one of these equations by negative 1 to change the sign. So I'm going to multiply the whole bottom by negative 1. All right, so we get negative y equals positive x minus 6. Okay, now we're going to add this equation with this one. So y minus y is 0 equals, bring down our negative x squared. 3x plus x is 4x. And then 2 minus 6 is negative 4. All right. Now this thing, we're going to try and factor. But first, it's bad to have a negative in front of your x squared. So what we're going to do is we're going to just multiply both sides by negative 1. And whatever you do to this side, you got to do to this side. So let's do that. So 0 times negative 1 is still 0. Handy. And then we're going to multiply negative 1 here. So we're going to get x squared minus 4x plus 4. The reason we do that is because you can't really factor something if you have a negative x squared. You want the x squared to be positive. So we're just multiplying by a negative 1 to change the sign. Now, we're going to do what we did on the last problem, and we're going to factor. So we want two numbers that multiply to positive 4 and add to negative 4. So this is going to be 0 equals x minus 2 times x minus 2. All right, negative 2 times negative 2 is positive 4. Negative 2 minus 2 is negative 4. So we factored correctly. Now same thing, set your factors equal to 0. X minus 2 equals 0. X minus 2 equals 0. Add 2. We get x equals 2, x equals 2. It's the same thing. What that means is that it's only going to touch in one spot. It's going to be, oh wait, was that 2 or negative 2? 2. 2 something. There's some like implications of this happening twice. You don't really need to trip about it. It's not that big of a deal. It means it has a duplicity or a repeated solution. It's got something to do with like, does it bounce off or come back? But it's not in this class, so don't worry about it. So we're 80% done. We've got the x. Now we just have to go get our y value. And the way we're going to get that is we're going to plug this back into one of the original equations. I'm going to plug it into this one that I crossed out because if we look, the y is already by itself. This could be super easy. So we're going to plug in our 2 here. So we have y equals negative. Plug in the 2 where the x was. Negative 2. Sorry, this is a positive 2 on the inside. Plus 6. So y equals negative 2 plus 6. Y equals 4. So 2, 4 is the only solution. There aren't two. This is one of those tangent ones where we've got a parabola and then we've got a line that kind of just comes and just whoop, gives a little kiss on the side there, and it only touches one time. So that was an example of one solution. You'll know it's one solution because you'll get repeated x values. Okay, there you go. So we've done a substitution. We've done an elimination. You could graph them. Here you go. There's a graph. So we know this is 0 solutions or no real solution. Okay, so no real solution. And we can tell that because of the graph. And you're going to say, Mr. Barton, how did you get these graphs? Well, the astute observer might see that this is just Desmos. So you just go type these into Desmos. But let's do it using substitution just so that we can see A, the quadratic formula again, and B, how will I know it's no real solution if I don't graph? If I graph it, it's really obvious. They don't touch. But what if I am a very math-inclined student who just loves formulas? How will I know it's no real solution when I'm doing it with the math if I don't look at a picture? So let's go do that. We're going to substitute this into that y. So we get negative 3x minus 2 equals 2x squared minus 2x plus 5. Now we need to move everything to one side so we can solve our quadratic. So we're going to add 3x and add 2. So this side cancels and is 0. That's good. 2x squared comes down because there's no like terms. Negative 2 plus 3 is 1, so plus 1x. And then 5 plus 2 is 7. Okay, this thing's not going to factor. I know it's not going to factor because there's no solutions. I know that because of the graph. But if you just try and factor this thing, it's not going to work and you're going to have a bad time. So if we have something that's unfactorable, you have to go use the quadratic formula. And let me give it to you just in case you forgot it. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, that entire thing over 2 times a. So write that down, copy that, memorize it. Better yet, get a tattoo of it so you can never forget it. So we're going to use this formula to solve this and see that there is no solution. What we need to do first is find a, b, and c. So a is the coefficient of x squared. So a is 2. B is the coefficient of x, and there's nothing there, so it's the invisible 1. So b is 1. And c is the constant, or the number without the variable, is positive 7. All right, let's go plug these into the quadratic formula, shall we? No, let's not, Barton. Let's not. Too bad, you don't have a say. So x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. All right, let's simplify this thing. X equals negative 1 plus or minus the square root. 1 squared is 1. Negative 4 times 2 is negative 8. Times 7 is negative 56 over 4. So here is the part where you can tell that this is no solution. If I simplify this stuff right here, we're going to get negative 1 plus or minus the square root of negative 55 over 4. You are not allowed to take square roots of negative numbers, right? This is a bad thing. This means you don't get a real number. This is actually radical 55i. We get an imaginary when you take the square root of a negative. No real solution. That word is a math word. It's not just a flavorful word. Like there's not a real solution. It's a made up. That's not what real means in math. Real is a group of numbers, right? There are another group of numbers called imaginary. There is an imaginary solution right there. You can see, you get your eye. So when we say no real solution, that means there could be an imaginary one, though. It's a different group of numbers. So as soon as you use your quadratic formula and you see that you get a negative inside the square root part, that's when you know there's no real solution. Okay. On your homework, though, I'm not 100% sure if it'll just say no real solution or if they expect you to give them the imaginary one, but we can. So this is going to be x equals negative 1 plus or minus. Turn this into the imaginary thing. The negative just comes outside and turns into an I. So this is the square root of 55i over 4. And then this is the imaginary solution. So I'm not sure if this will show up or if it's going to say no real solution. Because it's a college algebra class, I kind of expect this. So that's how you're going to do that. If you're going to get an imaginary solution, it's because the inside of your radical there turns negative. All right. So there's 3 examples for you with a special bonus imaginary example. If you have questions, let me know. Go hop in the WebEx. Tell me how much you hate math. Mr. Barton, this is terrible. I'm going to drop out. Wah, why does math have to be more than one step? Wah. I can hear you guys complaining already, and it's music to my ears. Go whine. I love it. It feeds me. You know what I mean? Don't forget to drop a like and subscribe. See you guys later.